Hi there, my name is Lorna McNeur, and I am presenting to you today my version of John Hejduk's 9-square grid project. I made this project almost 50 years ago at the Cooper Union in New York City when John Hejduk was the dean. The Museum of Modern Art has recently acquired this project, and before it left my home, I rather hastily made a video to explain or demystify what the 9-square grid project is all about. It is a bit rough around the edges, but hopefully tells the story well enough for now. Thank you for your interest. Okay, so this is the 9-square grid project, and it's what we call an architectonic tool for teaching first-year students about the underlying orders, the fundamental principles, and the philosophies embodied in architecture. What do I mean by that? First of all, the 9-square grid itself is a grid with a space at the center. And that space, the significance of that is that space is basically sacred space. It's primordial. It's a primordial condition of being human. In that, for example, that space could be the courtyards in various buildings, such that people can communicate across space and also gather in that space. Space doesn't always have to be in the center, but this is the ideal condition of that. So that's what I mean about some of the underlying orders. And so the ultimate significance of it being the 9-square grid is that it has that space. You can see that a 4-square grid has a column at the center, and a 16-square grid has a column at the center as well. So it's it's the smallest grid which has a space at the center. Some of these underlying principles are also, for example, core and periphery, path and place, point, line, plane, edge condition, boundaries, etc. So it's a modernist tool that strips it all down so that you can basically work with these principles without having to deal with sight, with context, with clients, etc. You're just working with design at its barest, clearest condition. The student also learns, whilst making the model, also learns about drawing in plan, in elevation, in axonometric. So you're going back and forth between the model and your drawings and your design. So you're doing all the motions of architecture whilst working with this very basic condition of architecture. Perhaps we want to have a look at some of the things that one would be thinking about. Basically, all of these boxes here contain various elements with which to start playing with these ideas and designing, basically. And we have square columns and we have round columns. At the moment, I've got round columns on the board. And so, you ask yourself questions like, how does a panel meet a round column? Well, if it was a square column, it would be quite simple. It would be just, if you wanted to butt it up against each other, you could. But a panel meeting a round column is really quite awkward. So it brings in other possibilities. So you can step the panel back and also set up a condition where there is a void around the column and the panels meet each other, but they don't actually touch. So you can start to work with shadow and light in those ways. Then a column, a round column might want to sit in a corner like that. So you come upon, you're working with an existing condition, and the column is not going to move, and you have to think about how you're going to deal with that column. And you can really end up having some rather poetic moments with these columns, doing the various things that they do and the way that the panels. So that gap right there that you're looking at, that could well be glazing at some point, instead of it just simply being that. So you're working with really, the fine-tuning of design in architecture. We also have various different elements which can bring you up to a second level. You really want to have these various different elements at your fingertips. So it's a way of playing with architecture on many different levels. Another level, the making of the model. Instead of just drilling a hole into a wooden board, having a wooden column and putting that into there, over time it will wobble. So it would wear out that hole there. So basically what I've done is to sink a copper sleeve into the base here, and also find little tubing here. This is plexiglass, this little column, and put a metal stud in there, which then meets the copper sleeve. So in that way, the young architect is thinking about longevity and what sort of detailing is going to keep this alive over time. And that's the sort of thing that you want to be thinking about as an architect.
I want to play.
Just to give you an idea of what these are all about. So these are vaults. And so we were asked to make triangular vaults, cylindrical vaults, and square vaults. And that's more like when you're getting into a double height grid. We've got cube pieces, and we also have these cylindrical pieces. And you might want possibly some thinner panels to play with as well. And the triangular ones are quite fun because, so far I've been working with the grid, but then of course the round columns imply rotation. So you can start, and the square ones imply working in parallel with them. So once you get the round columns in place, you're starting to work with something more dynamic conditions. And always thinking also about the shadows, shadow reveals. You can also think of butting pieces up against each other like that, and creating a dynamic interaction between the pieces and the columns. And so I think possibly you might be seeing that there are a great number of possibilities with this. And then, or if you want to continue that line of energy, you might pick it up like that, and it might be then pointing to a column, whereas here now the column is being held by the pieces, and now the column is almost as a punctuation point at the end of a series of movement. You can then, if you want, pick up this and bring that in there. And we can also see that there's some energy. This triangle is pointing some energy in that direction, which might possibly mean that we may or may not pick it up with a stairway, which then brings the energy back in to the space. So what's happening here is we're starting to set up some spatial movements on the board. And I personally tend to enjoy working with asymmetry within the symmetry of the 9 square grid. That's where I find the poetry and magic starts happening. Do something like that. So now we've got this energy, bringing it back in, and we could perhaps set it up like that. So this becomes quite a lovely space with like a columnar space, almost forest-like, whereas this is much more specific. It's a bit more intimate in here. And we're always thinking about how these guys are relating to each other. So we've spoken a little bit about design. We've spoken a little bit about the making, and the making is, the precision of the making is also really parallel, possibly synonymous with the precision of thinking. So what you're learning here is also, a way of thinking here as well. So if I've got that, I'm bringing some energy back into here, possibly along these columns here. Do we then take you back upstairs, or do we pick that up with a... So I'm using the thicker panels because they can tend to stand up more easily, but of course the thin, we have medium ones and we have very thin ones, and thin ones are, obviously incredibly delicate, and let's hope that they stand up. Oh, good, yes. And even so, you can start to turn corners. So that line doesn't have to be, literally that line. It's sort of like it picks it up and it brings it along and turns it, shifts through space. This is quite fun. Okay. So as a student, we were asked by John Hejduk to make all these pieces. So, you can come in and say, okay, today I want you to make 81 volumes, square volumes, or rectangular volumes. So you go about the business of doing that. And so again, I chose plexiglass for longevity. And also I like the weight of it. Each one is, I think, probably sanded about, I would say about 6 times, because you have to keep sanding, spraying and sanding, spraying and sanding, spraying and sanding until it becomes quite smooth. And then there are so many pieces that you really don't want them kicking around, because there are 81 of them, and they go right down from a large cube to a very tiny little cube. So I began making houses for all these pieces, and then I don't know if it was the same week or a different week. He said, now I want you to make 81 cylindrical volumes. So we do. And then he comes in and says, it's quite nice the way he says it, because he doesn't come in and demand. He just says, he likes to teach through osmosis. He didn't like to tell you a lot. He'd like to just give you a bit and you make it your own. So, he might say something like, I want you to make a U star. A U star. And that's how we would talk. So I got into, I said, okay, what's a U-stair? So we went away to find out what a U-stair is. And it's got a U to it, in your shape. And so you make a U-stair. And the first one you make might not have the curve on it. And the second one has that modernist curve on it. So then he wanted a straight stair. Then I was thinking, well, I remember that these stairs in Europe. When I was a child, we went around the world for a year. I remember, like in Italy and the European countries, these really, thin stairs wedged in between buildings. And I just got really excited about stairs. And so I made a lot more stairs than he asked for. And then I finally thought, well, what is the essence of stair? And so I thought, I'm going to see if I can capture stair in space. So this is what this model is all about. In this language, I wanted to see if I could capture that. So to make this, you basically cut this volume stairs, then you cut that volume stairs, and you hope and pray that they are going to meet each other really nicely. So we were reading at the time about Nude descending a staircase and Duchamp, and that to me felt like it was sort of capturing that moment in time of descending the staircase. I was thinking, okay, I've got all these stairs. Now what do I do? I don't want them kicking about, getting, sort of broken and chipped, etc. So I'm thinking I need to make a stair house. And I was reading about the mastabas, the chambers at the base of a pyramid. Also, I had been to Egypt as a 10-year-old, and we went up into the pyramids, and they were talking about those chambers down there. So all of this was in my head at the time. So I just felt somehow that making the stair house with chambers in it, and also recalling, just the interaction of sand and stone in the pyramids. And so I didn't want these stairs to be knocking about within the rooms, within the chambers. So I then put sand inside the chambers as well. And that just, the strength of that and the softness of the sand just seemed to speak to me. Okay, so we're just going to have a look at working with the double height grid. And the way that works is you take these copper rods here, which are actually hollow, and they in fact are just thinner than the copper sleeves that they go into. This is where they live. And I've threaded a few already. And then we use different columns, which are completely hollow, such that they can be threaded onto these. We're using square columns this time, just to make a change. And again, I won't take the time to put them all in at this point, but just to give you an idea. And then this grid has holes right through from top to bottom, so that one can thread these, which is not always easy, especially when you have 16 of them. Takes a little while for them to find their way. I might come down here and do this. There we go. Get in there. You go in there, don't pop out. There we go. That's great. So these guys sit here. Then we put these ones on top. This is where they live, so that they don't get lost. And these don't get chipped and lost. So, just to give you an idea of how it works, I'm using these columns, not all of them. And here's your whole set of the same sort of hollow columns, and they all sit on these little pegs that are stationary on the house. And then, since these are hollow, we now have little pegs sticking out of this one. This is the top grid that then sets in here and keeps it from sliding off. Let's see if we can get them to cooperate. Good. So that's your double height grid. And then this is, of course, one way of bringing you upstairs. And we have the slabs. Sit in here. And for example, you might have a curved panel down here. You might even have a double height space. I'm working a little bit symmetrically now. How do I want to do this? Yeah, okay, I'll do it that way. You come in here for some reason. You have a slab here so that you have the two curved panels, one below and one above, which are not literally connecting, but they are, especially from the angle where you are, so that they are a volume rising. But in this situation, you come into the landing and then might be taken perhaps over to here. So you just need to have all the pieces at your fingertips so you can play like this. Maybe we want to move that further back so that it's more spacious when you actually arrive. This is an example of this is just a very simple, straightforward example of that central space being important for, arrival and orientation and double height, and then bringing you up to then going in here, around there, and up again. So what happens is that, you might be working on the first level for quite a while until you feel like you're establishing something there. And then you might then add your second level on it and begin extending things through that are happening below that also not only extend through to the next level, but also start transforming as well. So basically what we're learning about is a number of different things. At the moment I'm talking about the spatiality of architecture, the human inhabitation, and moving through space, and how the architecture can speak to you and indicate to you where you need to go. So you are always, in communication and even dancing, with the space, with the building. And so the student is learning all that. That's on the sort of human spatial levels, but also all the other things that we've been talking about so far as well, in terms of the materiality, the choice of materials, the choice of detailing, the way that things are connected, and as John Hejduk says, working with post and beam structures. So you're looking at construction, structures, detailing, and spatiality and human inhabitation. So it's a number of different levels and layers of architecture embodied in this, seemingly simple tool, which gets more and more complex over time, till at the end of the year, a student is making something that is looking very much like a building. Well, I was afraid at the beginning of the year that I really wanted to work with John Hejduk, but I also was worried it was going to be too rational, this this project. But I said, never mind. We just are, I was brought up as an abstract expressionist artist. And I said, just put that aside. I'm sure you're going to be fine at the end of the year. You learn a lot. I think I was really surprised that how much of your own memories and your own sensibility can be poured into the project to make it your own, each of us. And that is how he teaches. And he talked about learning through osmosis, not doing a lot of hand-holding. And that, in fact, to be honest, that was the beauty of being at Cooper Union. Universities, but you really felt that students were really respected, and the quality of listening, in the presentations, it was sacred space in a way, because everyone was listening intently to the presentation going on, and then engaging in discussion. You could just tell by the interactions between the students and the staff that this was a place of learning for all of us, really, for students and staff alike. And, so that's what, these are the many things and much more that one has gained. The creativity levels and the personalization of the project itself, one has learned in first year, and then you go on to second year. You're now given a site, therefore a context, a client. It might be a community center, it might be a library. Then you're working with those layers of architecture. It might be urban, it might be rural. So you're looking at landscape or you're looking at urbanscape, and how the building responds and to all those situations and the needs of the requirements of the client, etc. And in third year at Cooper, people look forward to it as a year of analysis, of looking at historic architecture and or modernist. You might be looking at something on Palladian architecture, analyzing one term, analyzing Palladian villa, and then you might then move to Villa Savoie or Le Corbusier villa the next term, and just really explore it, on a lot very creative levels, to find out what's going on in terms of the dynamics of the building, the compression and expansion of the building, on a lot of different layers. So you're working, in each year you're just building your layers and knowledge of architecture. Fourth year moves much more into the philosophy, the sort of philosophical levels of architecture. It's often more urban. And then the fifth year is thesis. So basically a design exploration for the whole year of your choice of whatever it is you want to explore, and which in fact turned out to be, this is what this project turned out to be. That was my thesis year. Well, that's a whole other story. And that, in fact, to be honest, that was the beauty of being at Cooper Union. Made us, feel more respectful of ourselves and our own thinking and making and imagining. So it was a really beautiful place to be as a student.